Cristina, welcome. Welcome to the program.
Yeah, hi, Jim. Thank you so much for inviting me.
It's very nice to meet you here for the first time. You and I were speaking a little bit earlier, and I spoke with some of the other people from the labs. You're in Oracle Labs in Brisbane, which is sort of in my neighborhood of the world. I'm in Japan, so at least we're having a conversation that's mostly on the same time zone. And you are the director of the labs in Brisbane. So I wanted to talk to you about all things technology. You have a Ph.D. in computer science, so it's really cool. We can get into some interesting things and talk about the labs, talk about you, talk about the community, and talk about the technology that the people in the labs are sort of wrestling with every day. Because I do know that sort of product development and labs research and science, there's some overlap, but there's also a lot of differences. So I wanted to talk about that. So let's just start off with who are you? What do you do?
Right. Well, these days, I'm a senior director at Oracle, and it's been a long journey. As in, I've been in research for more than 20 years. Right. I did my PhD long time ago in the area of decompilation. So there was some of that security focus back then. And this security focus has been throughout all of the projects that we're focusing on for the past 15 years, initially at Sun and now as part of Oracle.
Yeah, you mentioned Sun. That's really cool because I came from Sun as well. So we were talking.
Right, yeah. And we never got to meet. Yeah, I used to be based in the San Francisco Bay Area back then.
Oh, really? So was I. I was in San Francisco. I worked in Menlo Park and Santa Clara. San Francisco. I was in the San Francisco office.
Right. Yeah, I was in Menlo Park.
Yeah. Well, there were 40,000 employees at the time, so pretty small by Oracle standards, but still at the time, 40,000 was a lot, right? So. Right. So, it's very easy not to meet somebody at Sun. But I was on the Open Solaris project, and I worked in Solaris engineering, which had a very large number of very, very technical people. Kernel development is sort of non-trivial. So I got used to being around people who could think very deeply about issues, highly scalable systems, things that just can't break for a lot of really important reasons. Lots of testing, lots of analysis, lots of design work, not just, hacking things together. And at Oracle, I've met a lot of people in the labs as well. And I see this very same mentality, this very same mindset, right? So, tell me a little bit about what the labs in Brisbane focuses on these days.
Okay, so these days we focus on a lot of projects that relate to intelligent application security. And so it's funny that you mentioned Open Solaris, because we did a lot of work with the Solaris organization when we started our first security project, which was a static code analysis tool called Parfait. And the focus there was to be able to find vulnerabilities in source code.
I remember that. Oh, wow, that's so cool. I remember having meetings about these tests. Really interesting. Wow.
Right, yeah. And back then, we were getting a lot of requirements from the Solaris engineers. Yes. And it was really interesting because from a research point of view, it was determining, okay, what can we do from research to be able to satisfy some of these requirements in terms of scalability of the tool, in terms of the precision of the tools. And so that was, fantastic work that got to be carried through all the way to Oracle. And we've now extended it quite a bit to support other types of languages, but we've also started then working on other type of tools as well. So not only focuses on the source code itself, now we also focus on what about all of your third-party libraries? What if there's vulnerabilities there that could be exploited? Especially because there's so many dependencies, right, on third-party code these days. Right. When you write Java applications, or if you write Python applications or Go applications, whatever the language, right? There's always going to be a lot of third-party code. So that's a different attack vector compared to attacking, vulnerabilities that may exist in your code. And compounded with that, we also started looking into the dynamic techniques. So what about if the application is already running? Can we actually be poking on that application to try and find ways of attacking the application to be able to find, like the underlying vulnerability that exists in the program and therefore be able to report that back to engineers, right?
So you say while it's running, so this is code in production live.
Correct. Yeah, they are. Like one of our latest projects really focuses on runtime applications self-protection. That's really like at the cutting edge of some of these application security techniques. Because imagine you have a database running or whatever, an application that is making use of a database. And could you actually determine the moment where you are being attacked, assumed through an SQL injection attack? And can we actually capture that in such a way that, we're preventing it, but also at the same time, we haven't introduced performance degradation on your application?
So this must be, especially now in this last 18 months or so, companies have millions of employees sitting at home in the kitchen like I am, right? And so, so we're accessing networks from home.
Yeah, right.
We're not necessarily in the office where the systems are professionally managed and secure. I got a little, home network here, right?
Right.
So what about that? Has that changed in terms of from a security point of view? Like when you deal with customers and people and engineers at the lab and also in the community?
Well, I think in general, you are seeing like a lot of attacks happening. And some of it is just because the types of attacks have changed over time. They're always changing, right? And they became more sophisticated, right? And these days you hear about ransomware, you hear about malware, right? And so it's not just like vulnerabilities, which is, like 20 years ago, we would hear about vulnerabilities. Now, these days we hear a lot more. There's a lot more that needs to be looked into. And so with the techniques that you develop, you really need to be looking at a combination of techniques, because one technique on its own is not going to be sufficient to provide a solution.
Interesting. So when you're dealing with these issues from a technology point of view in the labs, do you have any feeling about what the distinctions are between how the labs environment deals with these versus essentially engineering within a labs environment versus engineering within a product development environment? Are there a lot of similarities or are there some clear differences?
There are some differences in terms of like what the different teams can do, because normally like when you're in an engineering environment, if you're developing some of these techniques, you tend to use like techniques that have already been well established, right? Whereas in the lab, we can afford to have like a longer time frame and be able to invest in finding out what would be like a new technique that can actually provide a better solution, whether it's more efficient or whether it costs less overall, whatever that criteria may happen to be, but it provides you with a better solution longer term. And so that's really where we focus the distinction. And we work with a lot of the engineering organizations to be able to try out all of these ideas and, proof of concept, prototypes, and things like that, right? Like that's how we started working with Solaris, many years ago. And from that, we were like so happy, that the engineers, if you find like the right engineers that really care about like solving some of those problems, they're going to provide you with very good feedback. And so with that feedback, we get to improve our techniques, and then we can come back some months later and go like, hey, look at this. Is this better, right? And so you go through this process of refinement, having engineers that actually understand their code base and they can understand the value that the new techniques that are being developed will provide to them, right?
Cool. Is there a different type of engineer that is naturally migrates to a labs environment? Because, like you said, the time frames are different, and I suspect the thinking process is slightly different as well, because like you mentioned, to create something new, like you're not under the pressure of a release necessarily to fix an immediate situation. You want to sort of step back and find a longer term solution. That longer term solution might be a different solution, but you have to create it out of nothing. So I guess like I'm getting at is there a different type of an engineer or a different type of way of thinking in a labs environment versus, say, your product development environment?
Right. So in a labs environment, we normally end up having some of these discussions initially more with researchers. So, like people that have done a PhD in a particular area, in our case, program analysis or machine learning as it relates to security, right? Mm-hmm. And we're just trying to explore the ideas and the concept. But in order to make it a reality, we need engineers.
Okay.
And so we end up working, like if you look at any of my teams, they always have this mix in Oracle Labs. It's a mixed team that has researchers, engineers, they're all working together towards the same idea to be able to convert that idea into a prototype that is, robust enough for an engineering team to go and try it out over real code bases.
Interesting.
And,
okay.
I mean, you would be familiar with like the size of the Oracle code bases, the complexity of enterprise systems, right? So the proof of concept, prototype needs to be robust enough. Otherwise, the ideas that the researchers have cannot be shown, right?
Very interesting. So I was thinking more in terms of the distinction in thinking, but you're saying that there's actually a different function as well. You have you have like a researcher who's doing this, type of work, and an engineer actually has to implement it, right? And so they have to work together. There's two different groups of people, basically.
Right. Yeah. And what we find is that there are engineers that can work really well with the researchers because they have like specific domain knowledge in that area. Right. For example, like engineers that understand security vulnerabilities really well, right? They work really well with the team because they can explain and they have real examples as to when these things happen. There may be corner cases out there that, like a researcher may not be aware of, and they have that interest, right? And so it's a combination of multiple different things that really brings that team together.
Interesting. So what you must work with, Oracle is a very big company. There's lots of software here. What I would imagine you work with many different teams here. We spoke a little bit about Solaris, but what are some other groups that you work with in terms of the technologies?
Right. Yes. So we work a lot like with the Oracle database team. Mm-hmm. After Solaris, Oracle database was like our biggest, like team at Oracle. And from there, we have like a lot of other organizations. We have like the Java product group works with us. They have support for different languages, right? Not just like the one. Then we also have like the Oracle Cloud Infrastructure team. We have some of our global business units that we work with. So there's a variety of teams around the company that we really work with. Yeah.
So I'm interested. I've never been to Australia. I was supposed to go actually right before all the fun started in 2020, but maybe someday I'll get there. We have, in my job, we deal with a lot with our various communities, our developer communities around the world, and we have an active community in Australia. I'm wondering what about Brisbane? Why is there a labs there? Is that a tech hub in Australia? I'm speaking from complete ignorance here.
Right. Yeah. So I wouldn't say it's a tech hub per se. Like people think of Sydney or Melbourne before thinking of Brisbane from that point of view. However, there's very good people everywhere, right? Like throughout the country, Australia has like very strong technical people that graduating through all the different degrees. And why did we set up the labs in Australia in Brisbane? It's really one of these pragmatic decisions that Oracle Labs does. If you have someone that understands how to build an organization in that particular location and already understands like how some of the rest of the company works, well, why not do it in the city where they're based in? And so my family happens to live in Brazil.
Oh, okay. Okay, that's good. Because I've spoken with multiple people from the labs. I mean, I've spoken with Eric Sedler a lot, and for interviews, and a lot of the Graal VM team as well. I think I've done like 6 or 7 interviews with them.
Right.
Because I'm especially interested in open source, in terms of
Yes.
Building systems, new systems, but with external communities as well.
Yeah.
So,
Right.
all right, interesting. We talked a little bit about like the skills and the people, different functions in the labs environment. Can you talk a little bit about if you create something new, how does that, like with Graal, for instance, right? I mean, that was a long-term project in the labs, and now it's a product, right? Mm-hmm. So you don't have to speak about that specifically, but just the process of creating something new in the labs, brand new technology, and then eventually selling it or building a community around it, or whatever the business model happens to be, or the development model. How does it get out into people's hands?
Right. Yeah. So initially, like for us with our research projects, we tend to start small, in that a lot of our ideas normally tend to be 2 or 3 researchers getting together and starting with like, we want to look into this idea. Let's explore, let's see how much interest, how feasible it may be, right? Because you may have an idea, but in practice, nothing may come out of it. And so you do that exploration, and let's say that the exploration really ends up resulting on, hey, there is something, this idea can actually work out well. Then we start talking to some of the friendly engineering organizations that we've worked with in the past, so that they can be kind of like our guinea pigs. We're like, can we use your code for the following, and can you give us feedback, right? Because we still don't really know, longer term, is this going to pay out? But we want to start getting some initial feedback. And so through that process, you may end up saying, okay, this is not going to work out, or yes, this is something that is worthwhile investing more. And so you end up like growing the team more with engineers so that you can have something more robust. Sometimes we end up even rewriting part of the infrastructure, right? Like to be able to take it to that next step. And then you kind of go like from what used to be research into more of an advanced development stage, right? And once you're in that stage, when you're in advanced development, what you find is that you have like a lot of different engineering teams interested in your particular project, and then they're making requests for new features, changes, and so on. So you do start having some of this thinking around, like we need to have releases every so often, because some of the teams are starting to use the tool, but of course, if something doesn't work, they need a fix, right? Right? And then eventually we go through this process of technology transfer, right? And the technology transfer is really more like an incubation of a team so that they work more like an engineering team, right?
Interesting. So it sounds like the earlier stages are very organic. It could start off with a couple of people, sort of, testing something, scratching an itch maybe, or having a good idea, or trying to solve a problem. And then you go through a lot of trial and error, it sounds like, until something gels enough to say we have something. And then you start that more formal process of technology transfer. Is that sort of summarize it accurately?
Yes, but I would add at the start, when the researchers have this idea, we have normally been looking around in the company, what are areas where there are gaps, where, like new techniques for application security could actually help. And that really helps us be able to have kind of like a target for some of those ideas, because then we know like, if we could make this work, assume with Node.js, then we know there's this organization or that one that could use the technique.
Right.
Right? Or if we do this, but we focus purely on Java, which one is our target audience, right? And of course, at Oracle, quite huge.
Right, exactly.
Yeah, no, I was just going to say, like, there's all of these different languages that, there are different types of changes that are needed based on language, because some of the languages are static, other languages are more dynamic, right? And so the same type of techniques that you use for one language cannot necessarily work for all of the other languages. Right. So there is a big focus on that as well. And that's also how you end up with some of these complementary type of techniques overall.
Interesting. So you got a PhD in computer science. That's hard to do. A lot of time, a lot of study, a lot of effort. This must be something you love. I mean, there has to be something that you really are passionate about. I mean, I'm just observing you speaking. You have a lot of passion in your voice. You sort of light up, when you're actually speaking about these issues. Where did that come from?
I think, it was while I was doing like my undergraduate studies, I ended up doing an honors, like here in Australia, that's kind of like a 1-year degree before a master's degree. And with the honors, you get exposed to how to do a little bit of research, right? But at the same time, you have like advanced subjects. And amongst those subjects, there was the compiler construction subject. Not only that, there were special projects that you could take. And because I really enjoyed compilers, then I did like a project on translation of code. So my supervisor back then, Professor John Gove, he had this compiler for the Modular 2 language. Modular 2 is what's being taught at the university. And it used to run on all of these mainframe machines. But of course, at that time, you have to imagine 30 years ago, actually. So 30 years ago, PCs had become popular, right? And everyone was like, oh, can we have this compiler running on PCs? So John thought like, oh, we can do it if we have like a little bit of interpretation being done. So he came up with some technique. And so I ended up working on that project, translating, like an intermediate representation of all of this code that was being compiled into x86 assembler code. So from there, I ended up like going like, oh, wow, this is pretty cool how you can transform like the language, from a high level representation to a low level one. And so as a result of that, I ended up doing a PhD that focused on if you start from the low level representation from a binary, an executable file, how can you go to high level representation, right? Which was pretty new back then, right? Like decompilation. And it was actually ahead of its time because at the time, no one was working in that area. Whereas these days, when you look at the security community, decompilation techniques have to be used in a lot of different areas. And even like the NSA has made available their decompiler called Gitra as open source. Right? So times have changed quite a bit throughout these 30 years. But for me, it's all about program translation, right? I've seen it from high level to low level, from low level to high level, from high level to intermediate representation, which is where we're doing the analysis these days, right? So translation.
So does this come natural to you? Like when you were a little kid, were you always into sort of peeling things back to find the details and how they work? Does this just come natural, or was it acquired when you became an adult?
I think it's, throughout like my whole studies, yes. And since I've been, a kid, I've been very methodical. And so I do want to understand like all of the different parts. And if it's a challenge, so much the better, right? And I think these contain that aspect of challenge. Yeah.
Yeah, the reason I ask is just getting back to Open Solaris, we did a lot of community building at universities, and I would go to universities and speak at user groups and things like that. And I'm obviously a lot older than these kids were. And I noticed that there's a very significant delta in the thinking process between me and them. They were obviously much brighter than I was. These were all CS majors. I'm just sort of a generalist, but I learned a lot from those kids. They didn't realize. I mean, I was there to teach them about Open Solaris and get them involved in the community, and they can contribute. They can work with senior engineers and stuff like that. So I was giving information to them. I was educating them. But what they didn't realize is they were also educating me.
Yes.
Exactly. And I think one of the, when you talk about age, large age, differences, if you can get that reciprocal relationship, it's very, very important.
That's right. Definitely. And that ties in really well with what we do in labs, in that we enjoy working with interns. And it's that whole process, like they're coming like to help us with some aspect of one of the projects, right? So it's a small project. There may be an internship that is 3 months long, or it could be like 6 months long internship. It could be at the undergraduate level. It could be at the PhD level, right? But you also learn from them. Right. And it's really, really interesting, And we also find, like same thing happens when you're doing mentoring. That we do, of course, like a lot of mentoring also at Oracle Labs. And we're not only mentoring the students, we also mentor like some of our peers, through various different diversity and inclusion type of programs.
Right.
And you learn a lot. So and also a lot about yourself.
Yeah, exactly. So like what sort of, I don't know, advice or suggestions would you have for, say, high school kids, because they're going to be going into college, and then once you're in college, you're as you mentioned, once you're in college, you can be an intern. I mean, you're there, right? In fact, I went to several high schools in China, actually for sessions, Open Solaris stuff. I was with these children, but they were all generally really, really interested in tech. What would you say if you had a group of students, whether they were in high school or college, in front of you right now, in terms of ideas or suggestions or for the future?
Yeah, I think like if you're a student, like if you're in high school, very important like to be able to follow like what you really enjoy, where you want to go, right? Like because in high school normally it's like, what career should I be focusing on? Right. And it's really like, what is your passion? Because that's where you're going to perform at your best, right? Like you're going to be super interested in being able to follow that through, right? When you're in college, I mean, taking on any opportunity that gives you like real world experience allows you to see how to put in practice what you're learning in the context of industry, right? And that is, like a fantastic opportunity if you can do it like while you're still studying, because you get to understand how industry works. You also get to understand why you need to understand and study certain things. Right. I do remember, like my days at university, and sometimes we were like, what is this topic for? But back then there were no internships. These days, there's internship opportunities. And, even if you go into further studies, like a PhD degree, master's degree or PhD degree, those internship opportunities also exist with different type of projects, right? Projects that may be focusing more on research aspects instead of engineering aspects, but then you get to experience that while you're still studying.
Right.
And, fantastic, because then you get to really understand also for yourself, like, what do you want to do? Do you want to be, like a researcher in academia? Do you want to be a researcher in industry? So like an industrial research lab? Or do you want to be like a researcher that really is more applied and works more with engineering teams? And those three are very different roles.
Right.
And if you get that experience while you're studying, it helps you.
Yeah, this has been very helpful to me too. I've learned a lot in terms of some of these distinctions of actual roles. All these areas are of huge interest to me. So that's excellent advice. Thank you for that. For me, I'm sure hopefully they're listening too, but for me. So is there anything that, we've had a good discussion here. I've learned a lot, and I'm wondering if there's anything that we've left out. Is there anything else that we need to bring up here in this context? Anything you want to wrap up with?
So I think one of the areas that I wanted to tie back into something that you mentioned earlier on, you were involved a lot with Open Solaris and the community, right? And open source projects. Yeah. And, in my team, we've ended up working on all of these techniques and they're being applied internally inside of Oracle. However, in the past, year and a half, we started transforming ourselves, right? Oh. How can we do some open sourcing? And we have partnered with one of the local universities, the University of Queensland, to be able to have projects whereby, we're working with one of their students, but the whole project at the end of the day becomes open source.
Oh, cool.
So these days you can actually find us also online as open source.
Oh, cool. And where would people find that?
If you search for UQ cybersecurity.
UQ?
UQ for University of Queensland.
Okay.
So the hashtag is UQ Cyber.
Okay.
And UQ Cyber would actually find the right group at the University of Queensland. And you will find, for example, a project that we worked on that relates to automation of malware detection type of tools, right, which is a very timely topic these days.
Yes. Excellent. Okay. So would the code or the interactions, the mailing lists or the forums, would that be at the University of Queensland, or is it on GitHub, or is it?
Correct. It's in GitHub, but it's under University of Queensland. Yeah.
Okay, great.
UQ Cyber.
Okay, good. Actually, it's easier. Send me the link and I'll put it in the show notes.
Okay, yes.
That's the easiest way. We're actually describing people how they can search. We'll just give them a link. All right, great. Well, Cristina, it was a pleasure talking to you. I have a new friend in Australia. I'm making friends all over the place here, and
please visit us, Jim.
Yeah, it's not that far.
Olympics are going to be here.
Yeah, actually, it is pretty far. The world is much bigger than I thought it was. But anyway, Oracle Labs in Brisbane, Australia. Cristina Cifuentes. Thank you very much. We'll talk to you soon.
Thank you, Jim. It's been great talking to you today.
Thanks. Bye-bye.
Thanks. Bye.